Engineering 305, example problem. Not example problem. Sorry, this is a regular problem. This is problem 33 out of the back of chapter 6 or the middle of chapter 6. The motor shown in figure P30, P633, so it's kind of sticking out the bottom a little there, develops a torque. T is equal to 1,500 foot-pounds. You know I'm writing that down in the background. T equals 1,500 foot-pounds. The output torque from gears C and D are equal. Okay, so the torque of C is equal to the torque of D. The mean diameters of gears A and B are 12 inches and 4 inches. I'm going to write that right on my picture. I got the picture up too. So this is 12 inches, and this was 4 inches for gear B, respectively. If the diameter of the motor shaft is 2 inches, so that's a 2-inch there, and the diameter of the power shaft is 1.25, so 1.25 inches. We're going to start with find the torque in the power shaft between B and C. Find torque B to C. Okay. Okay. No problem. I'm good with that. Let's just start with that. And then we'll go back to the problem statement as we need to. I want to hide that. Is there anything we need to know? Well, you can see I've already got the diagram, so let's just get rid of that, and we'll start working on the problem. So the first thing is, and a little unfortunate. Yeah, maybe no. It's fine. We should all know that as this gear A goes around, the circumference is pi times d, that 12-inch diameter, and so. And the other one has to match it. It's pi d, but they're both traveling the same distance at, I get a different color here, at that interface. They both travel the same distance because they're constantly in contact with each other. So B is traveling 3 times as fast. So I hate that. So the speed of the speed of the off shaft, the speed of the shaft equals 3 times that of the motor. All right? And honestly, if you wanted to just state that was, we could just go back, assume, because this really isn't necessarily a part of this class, but it's a good thing to know. Speed of the shaft is 3 times that of the motor. That little one's got to spin and spin and spin to keep up. Well, then the torque, remember, power is equal, so power equals torque times speed. So therefore, the torque, since the power is constant, the power from the motor equals the power in the shaft. So if the speed goes up, then the torque goes down. So the torque of the shaft is equal to 500 foot-pounds. Now, I'm going to take a second to go look up the answer to make sure we're right before we proceed, because I didn't do that at the beginning. So here's a pause. Hold on. Nailed it! I knew that, but I just... Always good to check. Always good to check if you have the opportunity. All right, B. What's question B? I got to go back to the top. Find the torque in the shaft between C and D. Well, let's look at our picture. If what they said was those are both pulling off the same amount, so the torque of C plus the torque of D is equal to 500, and TC equals TD. Well, now I've got a system of equations, and essentially I can substitute in and get 2TD is equal to 500. Those are in units of foot, pounds, foot, pounds. And so TD is equal to 250 foot-pounds. And so gear C, that's also equal to torque at C. So for this section, it's at 500, and then I drop 250, and it's at 250, and then I drop another 250, and it's at 0 out here. All right? So the torque in the power shaft between C and D, torque between C and D is equal to 250 foot-pounds. Sorry. Third question. The maximum tensile and compressive stresses in each shaft. The maximum tensile and compressive stresses in each shaft. That is really interesting question. Because these shafts are not... What load on the... There's a load, there's a torque. That's all that we've got. We've got a torque being applied here. I don't have tensile and compressive. So what are they getting at? Well, C, sigma P1 and sigma P2. So first I got to find shear, and that's equal to TC over J. And so that's equal to, so for the first shaft, it's 1,500 foot-pounds. C, they told me about the geometry up at the beginning. The shaft, the diameter is 2 inches, so it's 1 inch in radius. 1 inch. And then J is going to be pi over 2 times 1 to the 4th. At least I like that. So that means that my torque is equal to, and I don't even bring my phone up here this time. Upstairs. Yeah, anyway. So 1,500 times 2, I'm gonna swap this around. 1,500 times 2/3, well, almost. And that's going to give me, let's see, I've got inches to the 4th here. And so that cancels with that. Oh, I got to do a 12 in there, don't I? I need a 12 inches per foot. And now I'm going to have it in pounds per inches squared. So that's PSI. But I thought I had 15 times 2/3, which was just 1,000. And then I've got to multiply it by 12. So it's a little bit bigger. But it's not terrible. That is going to be equal to the shear, got to remember, is equal to 11.46 in PSI. Sorry, that's KSI. I dropped a 0 there. KSI. And then if you remember Moore's circle, this is going to be tau max. So this is sigma P1 and this is sigma P2. That's my maximum tension and compression. So maybe I shouldn't even put another note here. Maybe I should put is equal to sigma P1 is equal to negative sigma P2. How's that? It's that value in tension or compression. So that's for that section. So the other thing they're going to ask me is in each shaft. Okay, so the maximum shear in the shaft is going to be at the beginning when the torque is equal to 500 foot-pounds. But now my shaft has got a different diameter. I'm going to multiply right away by 12 inches per foot. And then the shaft is 1.25 inches in diameter. So that's 5/8. So pi over 2 times 5/8 quantity squared. And I got to put the 5/8 up. Oh, sorry, not squared. Who's doing squares? to the 4th, and I got to put a 5/8 up here, inches, and so maybe I should just cancel those out right away, get rid of that, and put a 3 there. And basically now this is the same as what I had before. That's the same as what I had before. 500 times 12, 5/8, the pi over 2, 5/8 cubed. Already canceled it out. My feet, cancel with feet. I've got pounds, inches cubed down there, so I've got it. It's all good. And my answer in green, because I haven't used green yet, my answer is 15.65 roughly KSI, and that's equal to shear max equal to sigma P1 equal to negative sigma P2. There you go. I'm good. You guys good? All right. There's more to come. Take care.